Hello. So my name is Jeremiah Hudson. I am an undergrad at Michigan State, and I am working together with MSU Clued to help provide some calculus videos. So this is my first video on Calc 132, so Calculus 1, and this is going to be about limits. So kind of a couple tricks I do when working with limits, and just kind of how I understand it, outside of the classroom. So I took Calc 1 last semester, or last year, first semester as a freshman. And the way I kind of thought of a limit, is what does a function approach as you're going to what the limit wants you to go to? So that's a good way I was able to really work with limits, think of limits. I have a couple examples here that we'll go over for sure um, that I can help kind of explain along the way as well. So, and then I left a little note, some limits are tricky to find and you really got to work through them. And in class, they'll teach you a lot about that too. So for this first problem, it's just kind of a graph. This is just a good visual kind of exercise for understanding limits. So again, I just kind of look, right away, what is it asking us to look at? So it says t approaches 0 from the left. So on the number line, I look at, t is our x-axis in a way, and 0 is right here. We're approaching 0 from the left. It's not on 0. We're just approaching it. So it looks like it approaches this one right here. So -1. For the second part B, we're approaching 0 again this time, but this time from the right. So the little plus sign from the right. So as we approach it from the right, we're not at 0. As we approach it from the right, it looks like it goes directly to -2. Okay, so we put them both together. The definition of a limit, if we go at kind of one spot on the axis, or the x-axis, t-axis, maybe even the y-axis, we need both of those limits on the left and right to be the same for the limit as we approach that one thing to equal a single value. So if we look here, we approach 0 from the left, we get -1, 0 from the right, we get -2. So we will not have a limit here as we approach 0 together because these left and right values are not the same. Okay, so for D, as t approaches 2 from the left, okay, so we're looking at 2. I see 2 from the right, I see 2 from the left, and then I see the 2 value. So 2 from the left, it looks like we're going right at this y-axis at 2. So that's going to be that value there. If we look at part E and we're approaching 2 from the right this time, so we're looking at 2 and then the right, this is the function. We approach it from the right, it goes to 0. And then kind of the same thing here. We put them two together as we go to 2 all together. So we go from 2 to the left, 2 to the right at the same time. They have to equal each other for this to be one number, but they don't, so it's undefined again. Okay, so g of 2. So this was a little tricky for me too when I first started, but g of 2, that's just the value that's on the graph. So where is the value g2? Well, we know the open circles, it's not there, but this filled in circle, that's actually a point. That's actually, part of the, I don't want to say a line, but it's the point of g2. So that's going to be 1. That was a great one. Okay. And then finally, h, so the limit of g of our function as t approaches 4. So this is 4 from the left and right. This is what we're looking for here and here. Now, if we look at 4, it looks, it's smooth, there's no cuts. It's not jumping like the previous we had. So as we go to 4 from the left, we get, it looks like -3 or +3. And then as we approach 4 from the right, and I think I just did that backwards, then we approach 3 as well. So therefore we can say the limit of the function as we go towards 4 is just 3. So that was kind of a graphical example. It's a good way to kind of get yourself introduced to the topic and kind of work with limits. It's a good way to, kind of see what you're doing. The second part, I have 2 examples. So both of these examples really aren't going to be a lot of, manipulating the equation. You'll do that enough in class. This is just kind of like a thought tool that I kind of had problems with. And it's just like, it's useful. It, even if you don't know how to solve the limit in a particular fashion that you're supposed to, you can still come up with the answer. So it looks like we're going here, the limit as x approaches 1. So this is from the left and right at the same time. And our function is 2 minus x over x minus 1 squared. So I'll write it here. So we're going limit x approaches 1. This is from the right and left at the same time. So if we look at the numerator, the top, so we have 2, and we're subtracting it from something. So our value is approaching 1. So from both sides, this is going to approach 1. So this is going to be 2 minus, it's going to be a very close number to 1. It's going to be either, 1 from the right, which is going to be 1.0001, or 1 from the left, which is, 1 or like 0.999999, something very small, or very close to 1, not very small. So this is just basically approximately 2 minus 1, which is just 1. And then if we look at the denominator, this is going to be the tricky part. So we're subtracting a 1 minus a 1, right? So you'd think that just kind of goes to 0, but actually, since we don't have a 0 on the top, we can kind of just kind of look at it, think about what's happening here, and then we can actually find the solution to this problem. So if we think about what's happening, it's 1 minus 1, or a number very close to 1 minus 1. See, I even messed up there myself. So if we have 1 from the left, what's going to happen? Well, we're going to have 0.999999, something very close to 1, subtracted by 1. That's going to be a very small negative number. We're going to square it, so it's going to be a very small positive number, okay? Now let's see what happens if we plug in maybe, 1 from the right. So if we're approaching 1 from the right, so this is going to be maybe 1.000001. Even smaller than that it could be, right? We're subtracting that by 1, and then we're squaring it. So that's going to be a very small number, and we're squaring it again, right? So we're going to get the same outcome as we did before when we were approaching 1 from the left. So what's that going to yield? So we're doing a very small number squared. So it's going to be a very small number, right? So this is going to be like approximately, I don't want to say 0, but it's going to be very small, right? So we can say like 0.000.1. So if we have a number that's fixed on top, and we are increasing or decreasing really this number on the bottom, it's a very small number. You can think of, what's a good way to do it? So, 1 over 0.01, right? That's 1 over 100. So you can multiply the 100 through 1 over 100, flip it around, the limit's 100. So if we're doing that on the bigger scale, this is going to be a fixed number over a very, very small number. That's going to be approximately, or it's just going to be around infinity, and it's positive. I don't know why I did that. So positive infinity. And we didn't even really have to do any like tricks here. We just kind of thought about what it would be. So for this third example I have, this is the final example. So this is the limit as x approaches 2 from the right of x squared minus 2x minus 8 over x squared minus 5x plus 6. So I was looking at this for a while, and I was trying to factor it, trying to figure something out. And there's kind of, 2 ways you can do it. So you can do the bottom as x minus 6, x plus 1. And then the top's just basically going to be x minus 4, x plus 2. Or you can do x minus 3, x minus 2 on the bottom. So there's like 2 ways to factor it. It doesn't really matter either way. You're going to get the same result. So I chose the ladder method. So x minus 3, x minus 2 on the bottom, then x minus 4, x plus 2 on the top. So you look at this, we can't simplify this. And honestly, when I was looking it over, I totally forgot what I was supposed to do, if there was a trick to it. But I knew I could just kind of look at it and maybe just assess each term one at a time and see what was happening. So that's a good tool. This is a good tool overall to use if you're not, sure of a limit, and just kind of, thinking it out. So what's going to happen? So If we plug in this 2 right here, so 2 to the right, from the right, that's going to be approximately 2. We don't really have to worry about this -4 part. It's not so close to 2 that it's going to impact this at all. So this is going to be basically approximately 2. This top part, approximately -2, I'm sorry. So we're going to have a +2 -4, yep. And then on over here on the other side, it's a +2. We're just adding a number very close to 2, +2 again. So this is going to be approximately, +4. If we look at the bottom, same thing goes with here as the top for -4, but this is going to be -3 instead. It's not going to really impact. We don't have to pay too much attention to this. It's +2, -3. So what we can do is just plug it in, really. It's going to be basically -1. And then, so this part right here, so we have to look at this kind of, question mark. What is this part? So this is the close part. We have a 2 and we're subtracting it from a 2. So what's going to win out in the end? And that's going to determine, whether we have positive or negative infinity here. So a good way to think about it, is 2 from the right. So what does 2 from the right mean? So we're approaching 2, right? So we're approaching 2 from the right, from this way. So it's going to be a number barely bigger than 2, right? But it's going to be just about 2, but it's going to be barely bigger. So if we're subtracting a number barely bigger than 2, we're going to get that number. We're going to get that very small number, multiplying it by -1. So we're going to get a very small negative number. And then on top, it's going to be like a fixed, -8, basically. So we have approximately -2, approximately 4. It's going to be -8 over a very small negative number, right? So I even wrote it out right here. This is basically going to be these negatives are going to cancel out. We're going to get positive infinity as well.